if you're given tan theta equals 4/3, and theta is in quadrant 1, do you know what I'm going to do if I'm asked to find secant theta? First thing I'm going to do is I'm going to pull out my plate, and I'm going to look on the back, or I'm going to look on page 200 and see, is there anything on my plate that relates tangent theta and secant theta?
Yes.
Can you tell me what it is? There's a Pythagorean identity. Read it to me.
Tan squared theta plus 1 equals secant theta. Or secant squared theta.
Now, fundamental thing you have to know. What does it mean, tan squared? What is anything squared?
8 times itself.
It times itself. So tan squared means this is really tan theta times tangent theta. That is the rule for anything squared. Okay? So when you see tan squared theta, I have tan theta. What should I do with that?
D squared of 4/3 though?
What is tangent theta?
4/3.
4/3. That's tan theta. And when I want to square it, that's what I'm going to do. On the previous problem that you wrote down, did you square cosine theta?
Yes.
Well, I did. I put it on there, right? Okay.
Gotcha.
So I'm going to take that fraction tan theta plus 1 equals secant squared theta. And I'm literally just going to plug it into my identity. Okay? Then do I need to know what is 4/3 squared? Say it again. 16 over 9. I'm squaring the top. I'm squaring the bottom. 16 ninths plus 1. How do we add 1?
Denominator.
9 over 9.
9 over 9.
9 over 9. Okay?
Sure.
9 over 9 is 1. Common denominators. Okay? So 16 over 9 plus 9 over 9 equals secant squared theta. Do we add them together?
Yes.
What are we left with?
25 over 9.
25 over 9 equals secant squared theta. Is this what we wanted to find?
Yes.
Except.
Is that exactly what we wanted to find?
No, you have to do square root.
So we need to find what is the square root.
Oh, found it.
What's the square root of secant squared? Secant. That's really all I wanted. The square root of secant squared is secant. What do we do with a quotient, a fraction when it has a square root sign over the whole thing? Square root of the top over the bottom. It's the square root of A over the square root of B. Okay? So the square root of 25 is?
5.
What the square root of 9 is? 3. Now, should I question what quadrant I'm in?
Probably see if it's positive and negative.
See if it's positive. Anytime you take a square root, it can be positive or it can be negative. This time it was in quadrant 1, so secant theta will simply be
Positive.
5/3. We used an identity. This is what I'm going to be looking for. Okay? Did you use an identity to solve this equation? Yes. Is that a question? Awesome.
How'd you just do the square root?
When you have a square root of a fraction, it really is the square root of the top divided by the square root of the bottom. So what's the square root of 25 divided by the square root of 9? Noise it shouldn't go off.
Well, I was making sure that they weren't going to, because they usually is an alarm that was off at like 10:30, so they got remembered it.
Oh. Alright. Woo-wee. Morning. what about cosine negative theta? Can I use an identity to find cosine negative theta? Look on the back of your plate. Is there
Yes.
anywhere you see cosine negative theta?
Negative equal identity.
There's
Cosine
a
negative theta equals cosine theta.
negative angle. So you know this simply equals cosine theta.
And then,
And then, go ahead.
tan theta equals sine theta over cosine theta.
Okay.
I mean,
Do you know
way-
sine theta?
No, but we got somewhere.
What else do you know? We know tangent
Secant theta.
and we know secant theta. Is there any way to use either one of those?
Yes, secant theta equals 1 over cosine.
So what identity should we use?
Where? Reciprocal identity.
There's a reciprocal identity that says secant theta equals 1 over cosine theta.
Oh.
Okay,
I
so
thought we
that
said
would be-
tangent.
An identity to use. So,
That makes a lot more sense.
so when they're on the back of your plate, you have to determine, you have to be able to figure out which ones I need to use, which one. Sometimes there are multiple ones that you could use. But the last one I did use tangent theta equals sine over cosine. Right? In the example. That one didn't help me this time. So do we know secant theta?
Yes. 5/3.
5/3. Do we know cosine theta?
Nope.
No. Yes, ma'am. So, is this what we want?
I mean, yes.
Okay, I want what is cosine theta. How do I find what is cosine theta?
You gotta make it in the numerator.
Okay, what did you say? I can put the 5/3 in the bottom. What does that mean? 1 over 5/3. Okay. Or do you know that in math, if you see fractions, 1 over x equals 1 over 7, you can cross multiply, that would work. You can flip both. If you flip one side, you can flip the other. If I wanted to say 1 over x equals 7, I could still flip both sides.
That makes
So
sense.
can I do that with cosine?
Yeah.
So you can take the reciprocal on both sides. It's a math. What you do to one side, you just do to the other, and it'll say equivalent. So can I just take the reciprocal of both sides? So if I take the reciprocal of this, is that 3/5 equals cosine over 1? I'm going to put it there. It doesn't have to be, but just to show you that I flipped both. So what is cosine negative theta? 3/5.
I'm really confused on why cosine negative theta exists.
Thank
if it
you.
equals cosine theta.
Thank you for asking that question. Because usually what happens when we get here. So now I'm going to continue on your notes. What is cosine 30 degrees? Tell me that. So what are you doing? You find that, you determine what is the value of cosine 30 degrees. Oh, wait just a second.
So, if it's a half day tomorrow, does that mean that kindergarten gets out earlier or the same time as usual?
They technically get out earlier still, yeah. I mean they get out at 11:30 because dismissal is at 11:30. Normally they get out at 12.
Do you want a calculator
No, please.
Or- or
You should not have a calculator. You should not plug anything into a calculator.
okay?
Okay? This almost whole chapter is going to be without a calculator. Okay? So now, question is, do you know where 30 degrees is?
Yes.
Yes. Did you have to draw a triangle?
Yeah.
You have a 30, 60, 90, 1, 2, square root of 3 triangle, yes? What? Now, I need to make assumptions that we all draw it that way. 1 is always opposite 30 degrees, 2 is always the hypotenuse.
Good. I mean,
Square root
that's
of
how
3.
it is.
cosine 30 is
102.
what?
3 over 2.
Adjacent, 30 degrees
Where you
adjacent over hypotenuse.
Oh, my bad.
Okay. Okay. What quadrant are we in?
One.
First quadrant. Okay. Now, next problem. What is cosine negative 30 degrees? Which quadrant are we in?
Third.
What? Where's negative 30 degrees?
40.
Means you're just going down. How far?
30.
30 degrees. Which quadrant are we in?
4.
Fourth quadrant. Okay. What is cosine of negative 30 degrees?
Oh, it's positive.
In the fourth quadrant, cosine is positive, correct?
Yeah, because all students take calculus.
So whether we're going positive 30 or negative 30, cosine 30 is equal to cosine negative 30. Would you agree with this answer?
Yes.
Okay. Now, what I do not want you to hear, so I'm saying it really loud, so don't hear it. Okay? Complete
Yes.
oxymoron.
That would make sense.
It doesn't mean cosine's always negative, always positive. Okay?
It could be in the second.
What happens if we're in the second quadrant?
Negative.
So let's go, what's cosine of 150 degrees? So where's 150 degrees? Second quadrant. What's my reference angle?
30.
So this is 30. So what is cosine of 150 degrees? Negative square root of 3 over 2. Okay? Now, last but certainly not least, let's pick a different color. What's cosine of negative 150 degrees? Where is negative 150 degrees? I'm going negative. When I finally get to 150 degrees, I'm in which quadrant? 3 degrees. What's my reference angle? 30. What is cosine of negative 150? Okay? So all that negative angle identity says, it doesn't matter whether I plug in a positive or a negative, 30 degrees, I'm going to get the same answer. In that case, if it's in the first or fourth quadrant, they'll both be positive. If I'm in the second or the third quadrant, it doesn't matter whether I plug in a positive 150 or a negative 150, they'll still both be the same answer. And if they're in the second or third, they'll just be negative. Okay? Does that make sense?
Yes.
Does it also make sense why sine, cosecant, tangent, and cotangent are all negative? Do we need to go through this with those numbers, with those trig functions? Okay? Cosine is special because whether you go up or down on that side, it will be positive. It will be the same sign, positive, negative, on each side. Okay? Of the y-axis. So on the left side, the y-axis, it's all negative. The right side, it's all positive. The only one that does that. That's why it's special. We actually call it an even function because it does that.
But the others would rely on the x-axis.
Kind of, yes. Yes. So they're odd functions. Means like if you sine negative theta. Can we go? Do we want to look? Sine negative 30.
Sure, it'd be negative.
What's sine 30 degrees? I just have the triangles up here. What is it?
What do we do?
1/2. But what is sine negative 30?
Negative.
Why?
Because it's in the fourth quadrant? Yeah.
In the fourth quadrant. So it'll be negative of whatever sine 30 is. Okay? Does that make sense? Yes? No, maybe. All right.
As of right now, yes.
As of right now, yes. They're on the back of your plate. You can always reference them. Okay? There'll be a time that you will need them. Another thing, we have a wonderful Pythagorean identity that shows up lots of places. It should not be the first time you've seen it. You saw it in geometry. You probably, I hope, saw it in algebra 2, maybe. Maybe. Okay? Sine squared plus cosine squared equals 1. Okay? So can we rearrange and solve for sine? Can we rearrange? Or could we simply solve for sine squared? Could we subtract cosine theta from both sides?
Yes. And then
Could we say sine squared theta equals 1 minus cosine squared theta? That will
so
actually
it's gonna come out like Pythagorean, kind of.
kind of, what do you mean? Like, it kind of does look like an a squared equals c squared minus b squared. All of this comes back from the Pythagorean theorem, every bit of it. Well, just because a unit circle, the radius is 1, and 1 squared is 1. Yes. We can start, really what I start this with is x squared plus y squared equals r squared. Really, if I were doing this and deriving it for you, but I don't think anybody really wants it derived, right? You just want the information. Is that okay? All right, stand up. Yes, because you're asleep.
In every single class. So
Why? Senior
I'm just
thesis is
tired.
over. Be awake. It's happy time.
I'm so tired.
Is it over now?
Yeah, but that's
not
that's just not it.
I mean, for this quarter, basically.
But we still have panels.
But that's like 20 minutes.
And like Coach Jones had me sit up in his class, and I was falling asleep completely sitting up, like it was bad.
Like standing up.
No, like sitting straight up, like this.
He says that every time.
Sit up, like there's.
Welcome to the military.
That's funny. Justin slashes.
Okay,
So.
question. What is the Pythagorean theorem?
B squared equals C squared.
All right, everybody together.
A squared plus B squared equals C squared.
And when we plug in with sine and cosine x, y, and r, our most famous, most wonderful Pythagorean identity is what?
Sine squared theta plus cosine squared theta is 1.
Okay, everybody.
Sine squared theta plus cosine squared theta equals 1.
Can you rearrange them?
Yeah, you can.
You can rearrange them. Zach, go rearrange with the other Zach. Solve for something. Oh, we could do a Zach squared. Now, each Zach, I should have put you together. Stay together in the middle. No, never mind. Come over here, Zach. If I wanted to solve for cosine squared, do you guys figure out how we would solve for cosine squared?
Are we cosine now?
If I wanted to say cosine squared, what would you do?
Multiply.
How would you multiply?
Math. It's math.
No, you didn't. You really didn't. Could we take? All right, you can sit down. Zach, you can go back. What would you do though?
Well, we got to remove the 1.
How would we remove the 1?
I would go over here, maybe, and then another square would have to go over there.
Okay. So if we had a sine squared plus cosine squared equals 1. Ellen just got drew into this. You're the 1.
But who's sine?
Sine squared theta plus cosine squared theta equals 1.
I thought we were both cosine.
Sorry.
I did
I
too.
just messed that up.
Subtract over there.
So 1 from both sides, now we have a 0. Do you want to be the 0?
No, yeah.
You're not
Okay.
an
Really?
Does
individual.
that help us get cosine squared by itself?
You could.
Who's
No.
cosine squared?
No. We need,
He needs to come over with Ellen, and then Ellen needs to leave.
you go that way.
Okay.
What are you?
So what do we arrange with
So
now? What
I'm
is Ellen?
negative cosine
She's
squared.
1 minus sine squared equals cosine.
No.
So if we move the 1, y'all moved multiple places. If we want cosine by itself, are you
Oh,
cosine? Okay, so if I just want cosine squared by itself, what's left? What did I do?
Subtract the sine squared from both sides.
Really subtracted sine squared from both sides. Okay, so then we have 1 minus sine squared equals cosine squared. Okay, you can all go back to your seats and sit down if you wish.
0.
If we wish.
Okay. If you wish to stand up, but you just can't stand in front of me. So you gotta move around. These two, being able to rearrange, will become very, very critical. Okay? Being able to say, if I see a sine squared somewhere, guess what I could plug in instead of sine squared? 1 minus cosine squared. If I
Oh,
see
you can just-
cosine squared somewhere, guess what I could plug in? 1 minus sine squared. Okay, we are leading into something that's what we're going to be doing. Okay, we're going to start replacing. There's another wonderful green box. Oh, not yet. It's in the second section.
Getting ahead of yourself.
I am getting ahead of myself, but they started in this one. They rewrite things one as the other. Oh, I did. Can you write cotangent in terms of cosecant? Let's go to the last problem I gave you. Can you write cotangent theta in terms of cosecant theta?
See? It didn't go off. And it would.
Alright. Did you do this yesterday? If you did not, let's work on it right now. You know what I'm going to first look at?
I blame.
The back of my plate. Is there anything that's going to relate cotangent and cosecant?
1 plus cotangent squared theta equals cosecant squared theta.
Does everybody see that Pythagorean
No.
identity?
No.
Say it one more time.
It's on page 200. It's 1 plus
Yes.
cotangent squared theta equals cosecant.
Wait, I'm so sorry. Can you go back a page?
We started with a Pythagorean identity here,
Yeah.
and then we rearranged it.
Okay.
Okay?
So for
The first one, I didn't take the square root.
okay.
So all we would do is take a square root plus or minus, okay, of each one. But these are actually more helpful. We will actually use these two a lot.
Okay.
Okay. So here, if we want cotangent theta in terms of cosecant, what do we want by itself? What are we solving for?
Cosecant.
We're all cosecant is already really there.
Yeah.
So I want you to write. I don't know what I wrote on the paper. It says
Cosine.
write. Can you express? No, I didn't write it out very well. Can you express cotangent theta in terms of cosecant theta? So can we solve cotangent theta equals? What would we do first? What's our first step we would do? You think, Landry?
Subtract cotangent squared theta.
So to get cotangent by itself, you're going to move it to the other side.
No.
No, why? No.
You
that's
want
dumb.
cotangent?
Yeah, just subtract 1.
Just subtract 1.
Sorry. My tiredness brings out this stupidity.
Cotangent theta equals.
Surprisingly enough, so does my weakness.
Cotangent squared theta equals cosecant squared theta minus 1. Are we done? Do we have cotangent by itself?
No.
What else do we have to do?
Square root it.
Square root. What's the square root of cotangent squared? Cotangent theta. When you're taking the square root, what do you have to remember?
Square the other side.
Plus or minus the square root of cosecant squared theta minus 1. Now, algebra. Can we take the square root of these separate pieces when they're being subtracted? I don't know. Can we? Does everybody know this fact? A right triangle, it's a 3, 4, 5, is 3 squared plus 4 squared equals 5 squared. How do you know that's true? 9 plus 16 equals 25. Now, I'm going to do something to this. I'm going to take the square root of both sides. Okay? So when I take the square root of 5 squared, what am I left with? 5.
Oh, shoot.
If I take the square root of 3 squared and 4 squared, what you're telling me is 3 plus 4 equals 5.
Well, that's not true.
Is that true or is that false?
False.
It's false. Why can we not just take the square root of each piece?
Because you have to square them and then add them together, then square root those answers.
Yes. When there's a plus or a minus inside, you can't just pull it apart. Okay? This square root is like a parenthesis. It's a symbol of inclusion. Means you have to do everything under that before we can pull it apart. Okay? So guess what? This is your answer. You cannot simplify the right side at all. Okay? Even though I know the square root of both of these pieces, you cannot pull them apart separately. Now, the fun
So we
thing
leave
is
the two in
multiplication and division, you can. What did you say, Zach?
You leave the 2 in there?
What two?
The square root.
Mm-hmm.
Okay.
Most definitely. Most definitely. Okay? Did I give you one? Well, I did not. Because I knew that that was about as much as you could handle with me not being here.
We could
We can handle it.
Yeah, we just wrote that.
You just wrote it down. It's comprehension. Can you read it and take notes on what it says? I'm going to give you another something. Tan theta plus cotangent theta. Okay? For some reason, they start this in 5.1, but then they give you the whole box on what you should do with it in 5.2. Okay? The instructions will say, write in terms of sine and cosine. Sine theta and cosine theta, and simplify, or then simplify. Okay? So can we write tangent theta in terms of sine and cosine?
Yes.
Can you write cotangent theta in terms of sine and cosine?
Yes.
What are those two things called?
Cotangent theta equals cosine over sine.
Yes, what are those two pieces called?
Quotient identity.
They're quotient identities. Tan theta equals
Sine over cosine.
sine theta divided by cosine theta. What's cotangent equal?
Oh, cosine theta over sine theta.
Sine theta. Okay. Do what?
What else cancel out?
Question is, when you're adding fractions,
No.
can you cancel across?
No.
No. Why do we cancel? It's a division. We're dividing one by the other. There's no multiplication or division going on in between. So how do you add fractions with different denominators?
Gotta make them.
You gotta make them the same. So, question is, 1/3 plus 1/5. What do we do? So on this one, what are we gonna do?
3 by 5 and 5 by 3.
Oh, so close. When you multiply, are we just multiplying the 3 by 3? You have to multiply it by 3. Oh, stop. That was not 3. 5, sorry. But do we multiply it just by 5? Or do we have to multiply the top and the bottom by 5? What about the 5?
3.
Multiply by 3 over 3. Now, when you say multiply it by 3 and multiply it by 5, that's not what we're doing at all. What is 5 over 5?
1.
What's 3 over 3?
1.
Really, you're multiplying by 1. Okay? So if you're multiplying, go ahead and say it. I'm multiplying by 3 over 3 and 5 over 5. Okay? So what here is our denominators that we might need to multiply together?
Cosine theta over cosine theta.
Which one? Which one am I going to multiply by cosine theta?
The left one.
This one? Cosine over cosine. What's that denominator going to give me? Cosine squared. What's am I going to multiply this one by?
Oh, wait, so wait, I meant the right one.
So, like this, I'm not going to multiply 1 over 3 by 3 over 3. Started that and messed it up. So, cosine, what do we need to multiply by? Sine theta over sine theta. Correct? What about this side? Cosine theta over cosine theta. So what happens when we multiply these things together? We have sine times sine, which is sine squared theta over sine theta cosine theta. Plus, what about this fraction when we multiply? So sine squared theta over. If you have the same denominators, what can you do? Add them together. So what does our numerator end with? Okay, can we simplify any more?
Yes. No,
What?
you cannot.
I like your guessing. They're so much better.
No.
Yes.
Yes.
Why?
What do you notice? What's the top? Sine squared theta plus
Oh,
cosine
one.
squared theta is what?
1.
Sine squared theta plus cosine squared theta is what?
1.
1. So this is really, I try not to use equal signs.
1 over.
Really try not to. 1 divided by sine theta, cosine theta. Now, I'm going to ask, I know we're out.
Multiply by.
Why don't you use equal signs?
I don't like them in this. When we're just
So
simplifying,
then you can multiply both of them by the same.
really, I would pull it apart. I say it's 1 over sine times 1 over cosine. And that what's 1 over sine? Cosecant. And 1 over cosine is? So this is really secant times cosine. All right. Have a good day.